Hello everyone, I am Shruti Agarwal and I am going to discuss rocket motion. The motion of a rocket is an example of the system of variable mass. The motion is based on the Newton's third law of motion and the principle of momentum. Newton's third law of motion, we must have started you have started in the smaller classes that Newton's third law of motion states that for every action there is an equal and opposite reaction. Now the rocket consists of a combustion chamber. This is the combustion chamber in which the liquid or the solid fuel is burnt. Now what happens is the heat of combustion raises the pressure very high inside the chamber. So the hot gases are expelled from the chamber. So the hot gases are expelled from the tail of the rocket in the form of a jet with a very high exhaust velocity, and the rocket moves in the forward direction. It exerts the force of action on the gas jet in the forward direction. These are the internal forces in the system. Now, a system means the rocket and the gas. This is the rocket and the gas. In the absence of the external forces, what happens is the momentum of the system becomes constant. The gas jet acquires the momentum in the backward direction and the rockets get equal momentum in the forward. Now, this is the rocket. Now, let m be the mass of the rocket plus fuel and v be its velocity at any time t. Let an amount of mass ejected from the rocket, this in time dt in the form of gas jet be dm. If u be the velocity of the gas jet, then its velocity relative to the rocket Vr will be Vr is equals to u minus v. This is the equation 1. Now Vr is the exhaust velocity. So from Newton's law of motion, Newton's second law of motion, we have m dv by dt is equals to Fe plus Vr dm by dt. Now this Fe is external forces acting on the system, and this Vr dm by dt is the force of reaction exerted on the system by the leaving mass. Now the force Fe is the gravitational force. This force Fe, the external forces, this is the gravitational force, and the air resistance on the rocket. If we neglect the air resistance and the change in gravity, then what happens is then Fe is equals to mg. We already know mg, the formula for the force F is equals to mg. So Fe here is the external forces and the m is the mass of the rocket plus fuel and g is the gravity. This is the equation 3. Now putting the value of Fe from 2. This is the 2 equation mdv. From this equation we'll take the value of Fe from 2. We get m dv by dt is minus Vr dm by dt is equals to mg. We are taking this term on the right hand side. We get m dv by dt is equals to mg plus Vr dm by dt. This is the equation 4. If the rocket moves upwards, then v is directed upwards and Vrg downwards. If the rocket moves upwards, this rocket, if it is moving upwards, then the rocket moves upwards, then v is directed upwards and Vr and g downwards. V is in upward direction and Vr and g in downward direction. Okay. So then we have m dv by dt is equal to minus mg minus Vr dm by dt. Because they are moving in downward direction, so sign will become opposite. Sign will become minus. So taking out the value of dv, we get माइनस जी डी टी, इसको हम लोग एम बाई डी टी टर्म को हम लोग विल टेक ऑन द राइट हैंड साइड, विल मल्टीप्लाई इट With the right hand side equation, we get minus g dt minus vr dm by m. Now integrating this equation, when the motion starts at time t is equals to 0 with velocity vo and the mass of the rocket and fuel is mo. Okay, we'll integrate at time t is equals to 0, the velocity is vo and the mass will be mo up to an arbitrary time t. We get integrating dv from vo to v, which is equals to minus g integrating dt from 0 to t minus vr d integrating dm by m from mo to m. This is initial and this is the final, as we already know in the integrating. This implies v minus vo is equals to minus gt minus vr log e m upon mo. This implies v is equals to vo plus vr. We'll taking this here right hand side. We get this equation where t is the time required for burning all the fuel. Here m is the final mass and v is the maximum velocity attained by the rocket. On neglecting g, we get v is equals to vo plus vr log e mo upon m. This is the equation of motion, rocket motion.